Okay, so in the previous lesson we talked about the equation of a linear relation, which is in the form of y equals mx plus b. M is our rate of change, b is our vertical intercept or our initial value. Okay, so if you have the m and b, you can write the equation of the line. So we're gonna write the equation from words, graphs, and tables. These are basically our four representations of the linear relation. You have to be very comfortable going from one form to another. So for example, if I give you the graph, you should be able to generate the table of the linear relation. You should be able to generate the equation of the linear relation. And you can also express the linear relation in words. Okay, so we're basically starting from one form and going to the other three. So in this lesson, we're going to start with words or graphs or tables and then going towards the equation. So always keep in mind with the equation you need the rate of change and the vertical intercept or the initial value. Okay, so a taxi charges $1.65 per kilometer plus a fixed charge of $3.50. So you know what? There are two numbers here. Okay, $1.65 per kilometer and the 3.5. So one of these numbers represents the rate of change and one of these numbers represents the initial value. Okay, so hopefully take your time and hopefully you get the right answer. I'll give you a hint. The units really give it away. It's very clear to me when I read the question which one has to be the rate of change. Okay, so this $3.50, this can't possibly be the rate of change, right? There's only one variable here. There's only dollars. Okay, we're only talking about one thing, $3.50. Whereas the $1.65 per kilometer, that's a rate of change. You're charged an additional $1.65 per kilometer traveled. That, like, it screams out rate of change. So here, in this case, M is 1.65, okay? And B is 3.5. Okay, this is our initial value. So once I hop onto this taxi, bam, $3.50. Okay, so that's the way they charge a ride, and you have to live with that. So you hop on, $3.50, and for each additional kilometer, it's an extra $1.65, which makes sense because if it's a long trip, it should cost more money. So I'm not going to use X and Y. I'm going to use C for cost of the trip and D for the distance in kilometers. You don't have to use the letters I've chosen, but I think they make more sense and you'll be less likely to make a mistake. So 1.65, that's our rate of change. 3.5 is our initial value. And if you were to graph this, the 3.5 will be our vertical intercept. So you know what? I'm going to even give you the let's C represent cost in dollars. Let D represent distance traveled, and that's in kilometers. Okay, all right, next one. Raymond earns $8.50 per hour at his part-time job. Raymond earns $8.50 per hour at his part-time job. Now here I only see one number, so let's just circle this number here, $8.50 per hour. Is that an initial value or is that a rate of change? That is definitely a rate of change. It's $8.50 per hour. Okay, what about B though? What about our initial value? Well, if you think about it, it makes sense to put 0. If he didn't work an hour, he's not gonna make any money, right? If you're sitting down on a table watching TV, you don't deserve money. So no money here. So B, our initial value, is $0. If Raymond doesn't work, he is not getting a penny. So let's do E for earnings. And let's do T for time in hours. So 8.5 T. You could write plus 0, but that's just silly. That's just unnecessary. So let E represent earnings, and that's in dollars. Let T represent time in hours. Okay? So he makes $8.50 per hour. So we're going to move on from words, and we're going to start from a graph instead. But I just want to reiterate the fact that no matter what I start you off with, the goal is always the same. We want to be able to extract the rate of change and the vertical intercept or the initial value. Okay? So usually for vertical intercept, that's for graphs, and initial value, and that's from words. Okay, so what is the vertical intercept? Because I'm given a graph, so I can tell you. Hopefully, you can tell me what is the vertical intercept. Where does this line intersect with the vertical axis? Well, right here at the origin. So guess what? B is equal to 0. Okay. What about the rate of change here? So I'm going to use these 2 points. Okay. The rate of change, which is m by the way, is equal to, ooh, be careful. Please don't say the rise is 2, because a lot of students say the rise is 2. No, the rise is, the scale is 1 block is 50, so 2 blocks is 100. So rise over run, just in case you forgot, which is 100 over 4, which is 25. The rate of change is 25. 25? What is the units here? So by the way, this is cost versus number of customers. So we're looking at an extra $25 per customer. Okay, so I'm going to write the equation. We're going to do a C for cost and N for the number of customers. So C equals 25N. Please don't write plus 0. I mean, if you really want to, you can, but it really is unnecessary. So C equals 25N. C representing the cost, and N represents the number of customers. You can write some let statements if you want, but usually I will assign the variable. I will tell you C has the, in fact, I will put it, I'll label, I should really have the labels here. So I'm basically forcing you, I'm forcing you what the variables are. So I force you to say C to be the cost and N to be the number of customers. Okay, so let's do over here. Height of balloon versus time. So I want to force the height to be H and time to be T. Okay, so 2 things. I need the rate of change and the vertical intercept. So I'm going to start with the vertical intercept because I can just open my eyes and I can see that the vertical intercept is 100. What about the rate of change? The rate of change, let's do these 2. Please use a scale, 100 to 80, so that's -20. And here, that's 4. So -24 is -5. -5 meters per minute. So this balloon is dropping 5 meters a minute. Okay, it's getting closer to the ground by 5 meters every single minute. So let's write the equation. So H is equal to -5t plus 100. Okay, so you start off 100 meters off the ground and you get closer and closer and closer to the ground. You're going to get closer by 5 meters every minute. Okay, so now I'm going to start you off with the table, and your goal is to write the equation. So Once again, the strategy doesn't change. The strategy is to find the rate of change and find the initial value. So you know what? Right off the bat, initial value, B is equal to 300. The cost of the banquet, even if nobody comes, the renting cost of the banquet hall is $300 right off the bat. Okay, you'll be very sad if no one came to your party, but you still got to pay $300. Okay, and now let's talk about the rate of change. So the rate of change, okay, you can find the first differences, which will be your rise. So this is going to be 250, 250, 250, 250. So your rise is 250. Oops, your rise is 250. What about your run? Because we need both rise and run to find the rate of change. So this is plus 20, plus 20, plus 20, plus 20. You don't have to do all of them actually. But you should see that you have to make sure that the independent variable is increasing by a constant amount, which it is. So the run is 20 and the rise is 250. So that just triple check. That's right. Yeah, $12.5 per person, which is super cheap. $12.50 per guest. So C, and like I said before, I will force you to. I'm forcing you to assign the variables. So I will tell you that cost of a banquet is C and number of guests is N. So C is equal to 12.5. The rate of change is 12.5 N plus the initial value of 300. So it costs initially, right off the bat, $300 plus an additional $12.50 per guest coming to the banquet hall. Okay, one more. So we have kilometers driven and gas remaining. So I'm going to assign the variables right now. So this is going to be D here, and gas that's volume. Okay. All right. So I'm not going to fill in find all the first differences. I'm just going to do this. This is -8, and this is 100. Okay. I'm just going to make sure we're going up by 100 here, and we're going down by 8. Yep. Awesome. So rise, run. Okay. You don't have to fill in all the values here. Rise, run. So rate of change is equal to -8 over 100. You can change it to decimal if you want. A lot of students prefer decimal, so -0.08 liters per, oops, not per minute, per kilometer. So each kilometer you drive, you are consuming about 0.08 liters of gas. And the initial value is 40 liters. So right off the bat, you have 40 liters in your gas tank. So I have found the two things I need to write the equation of the line. I need the rate of change and the initial value. D plus 40. There's your equation. So we were able to write the equation of the line when we're given words, when we're given the graph, and we're given the table. But basically it's the same strategy no matter what you're given. You want to be able to extract the rate of change and establish what the vertical intercept is, or the initial value. All right, so we'll practice some more on the next video.